right, so this is just going to be a short video on when to use each of the trig functions. So I'm going to go ahead and write SOHCAHTOA at the top. So remember, SOHCAHTOA helps us remember the ratios. So this one is that sine is your opposite over your hypotenuse. This is cosine is your adjacent over your hypotenuse. And then tangent is opposite over adjacent. So starting with these first two, we have a 32-degree angle, and from the 32-degree angle that we're concerned about, we know that this is our opposite side and that the x is our hypotenuse, because remember, our hypotenuse is always opposite of the 90. So picking your trig function is simply based off of what sides are you given, and what angle are you referring to? So because where we are referring to the 32, we would have sine of 32 equals opposite of 5 over hypotenuse. So I picked sine because my sides were the opposite and hypotenuse, so that gives me my O and H. And so when you write it, you cite your trig function, the degree, and equals to whatever ratio it is. So if you look at the one to the right, this one is slightly different because now I have my 5, which is still opposite the 32, but my x is now adjacent rather than the hypotenuse because it's a part of the triangle. So because my sides are now opposite and adjacent, I have to look at my SOHCAHTOA. Opposite and adjacent only happens in tangent because it's opposite over adjacent. So because I have that, I would have tangent of 32 equals opposite over adjacent. So when picking your trig functions, you're really just looking at what side am I given and what angle am I referring to. So let's scroll down and look at these ones. Too purple. All right, so looking at this, we have a 51-degree angle. And then we know we have this side off to the left and 7 off to the right. So noticing that I'm looking at my 51, I see that x is opposite. And a really easy way to see it is that this 55-degree angle is made up by those two lines. And notice the opposite side is not highlighted. So that may be one trick that you use in order to help you identify your opposite or your adjacent. But then the 7, because it is a part of what makes up the angle, is going to be adjacent. You want to be careful because notice this one is flipped kind of funny, so our hypotenuse is actually on the bottom. But because I have opposite and adjacent, using SOHCAHTOA, because we have opposite and adjacent, we know we're going to be using TOA, that tangent. So you write tangent because that's our trig function of the angle we are talking about, 51 degrees equals opposite over adjacent. And it's easy as that. And then to solve it, you'd multiply by 7 to both sides. For this one, notice that I switched where the x was. So now, looking at it, again, to help you, it's 7 is our adjacent side, and x is our hypotenuse. And so you want to be careful because it is really easy to mix up adjacent and hypotenuse if you're not careful of where your hypotenuse is. So because we have our adjacent side and our hypotenuse, so those are the two things we're going to be looking at, and we are using the 51 degrees. So adjacent and hypotenuse would give me cosine because we have the A and the H. So we have cosine of the angle I'm looking at, 51 degrees, is adjacent 7 over hypotenuse x. Okay. So then with this last one, we're going to do the same thing. Boop. Oh, there it goes. All right, so still need our SOHCAHTOA because when you're picking your trig functions, you need to know what ratios you're looking at. So with this triangle, we have our hypotenuse, which is opposite of the 90, and then this 12 degrees, we have this x that's right next to it, which is going to be our adjacent. And then our opposite side would be the side that is not made up of the angle. So looking at this, I have an adjacent and a hypotenuse. So because I have adjacent and a hypotenuse, that's going to give me cosine A and H. So we have cosine of 12 degrees is our adjacent over our hypotenuse. And you multiply by 10 and then solve. And then for the one on the right, it's slightly different because now our x is not right next to the 12. We still have this 10 as our hypotenuse, but x is now our opposite side. So because I have opposite and a hypotenuse, now I'm looking for O and H. So I know I'm going to be using sine. So we'll have sine of 12 equals our opposite, x, over our hypotenuse, 10. And that is how you decide when to use sine, cosine, and tangent. If you end up getting into inverse trig, you're going to do it the same way, and I don't have it pre-drawn. But let's say you want to do inverse trig and you had a right triangle and you were trying to find this angle down here and you knew that this was 7 and let's say 12. Well, looking from this angle, 7 is our opposite and 12 is our hypotenuse. So still looking at the same rules, because it's opposite and hypotenuse, it's going to be sine, but because my angle is my unknown, it's going to be inverse sine of opposite over hypotenuse equals, we'll call it A, and then you'll actually get your degree measure from that. And so if you were looking at, let's say, this angle up here, it just slightly changes because now if you're up here, now 7 is my adjacent side and 12 is still my hypotenuse. So then because it's adjacent and hypotenuse, we would use inverse cosine of adjacent over hypotenuse. So depending on what you're given and what you're being asked for is going to change how you, or which trig function you're going to use. But you're really looking at what angle are you referring to and what two sides do you have. If you get that down, then trig will be no problem.